Sweet Simone.
Hi, Miss Fair.
Hey, Angel.
How
How
are you?
are you?
I am not feeling too good. I'm a little sick, but that's okay.
Oh, darling, I'm sorry to hear that.
It's okay. Thank you.
How can I help you today? You're the
Oh,
only one that
yeah.
showed up.
I had a couple questions about the worksheet that Miss Wynn gave us.
Can you tell me what that looks like? Is it like a practice A or something, or did she make it up?
It just says like the remainder and factor theorems at the top. It's
Okay.
not like a practice anything. It's just
Okay. I may have to because I don't have a copy of that. She may have made it herself. So what we'll do is I'll have you read me the problem
okay.
and the instructions and we'll go from there. Is that okay with you?
Yeah, that's fine.
All right. Let me pull this up. Hey Momo, it's Simone on Math Lab.
Hi, Momo.
Momo just got home from school
Oh
from
yeah, I got
yeah,
home like a couple.
anatomy and stuff. Yeah, I do want to at least on Tuesdays try to make the math lab in the afternoon. Everybody says they like it better when it's a consistent time, which I understand, but it's so weird because if I do like 11 o'clock in the morning, then you guys can't come. You know what I mean? So what
Yeah.
I want to do is do like one between 1 and 2 on Tuesdays and do like 11 on Thursdays.
Yeah.
Uh, Simone, has anybody else joined?
No.
No, but it's recorded. So,
I know. I was just wondering.
yeah, no, she's all by herself. I didn't know if you were going to spill some tea or something, you know. just just have to all right, baby girl, let me share the screen with you so you can see my pretty blank screen that we're fixing to do our problems on. Fixing to. That's my Tennessee girl in me coming out. All right. Do you want to okay, you want to just start from the beginning or what do you want to do, love?
Well, I think okay, so like the most of it is just like synthetic division, which I totally understand.
Uh-huh.
But then one of the sections says to use synthetic division to determine whether the numbers are like the numbers given are roots of the polynomials
Okay. Use synthetic division to determine whether something is a root
of the polynomial. Yeah.
is a root of the polynomial. Okay. Well, let's
So,
let's walk and talk that out, okay?
so
Um
like
so a root, just so that you don't ever a root, a zero, and a solution to a polynomial all the exact same thing.
oh,
Okay?
okay.
It's also the x-intercept.
Okay.
So it's where that polynomial is going to cross the x-axis. It's either going to touch it or cross it, and we'll get into that a little bit later too. Touch or cross. Okay?
Yeah.
Okay. So just to kind of clarify that, all right? Let's just start there. Because sometimes that helps if you can kind of get a visual. Okay. Then what, baby?
Well, I did the synthetic division part for them,
Yes, ma'am.
but I just didn't know like how to
What to do
determine.
from there?
What did you say?
What to do from there?
Yeah.
All right. Well, can you give me the first problem?
Yeah. Okay. So
What is it, love?
it gave the numbers -3 and 2.
Negative 3 and 2. All right. And what's the polynomial?
It says px equals
P.
3x cubed.
Oh, P of X, like that
Yeah.
equals. Okay.
3x cubed plus 5x squared minus 6x plus 18.
Okay. Did I write it right?
Yes, you
Yeah,
did.
the struggle is real sometimes for me. Okay. So we're going to go down here.
I did like the synthetic with like the 3, the 5, -6, and 18.
I just have to catch up to you now. Okay. Because it'll help if I've got the same numbers and everything in front of me. You know what I mean?
Yeah, right.
To help you. It probably if not, it won't make much sense.
Yeah, that's true.
Okay. So see how this number right here is a 0?
Yes.
That means if this is the remainder, okay?
Mm-hmm.
And that means that this is, in fact, a 0 or a root or a solution, because that means that I can divide. But if I wrote it as a root or a factor, it would look like this. Okay? That's the
Okay.
factor. That means that this is a factor of that.
Oh,
So
okay.
0 looks like this, but the factor looks like that. Because technically, if I sat x plus 3 equal to 0, it would, and solved, it would look like that. And that's why.
Okay.
Okay.
So
So this was the factor. That's the root. And the original question was to determine whether it is a 0. Is that correct? Or a root? How did she ask it?
it says a root.
A root. So it is, in fact, a root. If this number here is 0, it's a root.
Okay. That makes sense.
Okay, good. Now, if it then asked for this to be written out, I just want to show you this. 3x squared minus 4x plus 6. This is the how you would write it in quadratic if you're ever asked to do that.
Okay.
It's always 1 degree smaller than what you started with. So if you started with 3, this is a 2. If you started with 4, that would be a 3. Does that make sense?
Yes, that makes complete sense.
Okay, good. All right, so then the next thing, we're going to plug in that 2.
Mm-hmm.
Okay. And we're supposed to, you could do a number of things actually if you wanted to, Simone. You could actually factor this and see if you get a 2, or you can just go back and do synthetic division all over again. It's strictly up to you. Did that make sense or did I lose you?
Wait, factor it and see if there's a 2 in it?
You could factor this and
Okay.
see if 2 was a factor of it, or you could go back and do synthetic division.
Yeah, I'd probably just go back and do synthetic so I don't confuse myself.
Okay. All right, cool. I just want to make sure that I'm showing you all of the options,
Yeah.
so you can do it either way. All right. So I plugged in all my numbers again, and I'm going to do synthetic on 2 to confirm that there's no remainder. So I'm going to bring down my 3, and 3 times 2 is 6. 5 and 6 is 11. 11 times 2 is 22. 22 minus 6. Oh, Lord Jesus, please help me. What is that, 16, Simone?
That's what
Okay, and 16 times 2 is 32. And then you would actually add those, and then that's going to give me a 50. That is 50. So obviously it is not. It has a remainder because this is the remainder.
Uh-huh.
Okay. If it has a remainder, it is not a 0. If it does not have a remainder, it is a 0.
Okay. That makes sense.
Okay, great. And let me I'll just take it back to, like, if I was dividing 3 into 19, okay?
Uh-huh.
It would go 6 times with a remainder of 1, right?
Yes.
So that means 3 is not a factor of 19 because I got a remainder. Remember way back then? when we used to get remainders, and I was like, oh, it doesn't go into it evenly, so it's
Yeah.
not a factor. It's the same principle except on a bigger scale.
Okay, when you explain it like that, it makes more sense.
Oh, really?
Yeah.
Yeah. Oh, well, good. I'm glad. Momo liked it too. So I had a win-win. That's a real victory for me. You'll get one today, I'm sure, honey. So in just by the same token, if I divide 3 into 18, 6
Six.
goes into it evenly, and there is no remainder. So 3 is a factor of 18.
Okay.
And so it's just that same exact principle. Except the really cool thing is, in all this complicated mess that you see here, they just have great words for it, like root and zero and solution and x-intercept. And then so like what this means is all this big fancy function that I have here, it's actually tells me that it's going to cross the x-axis at a -3.
Oh.
Yeah. So it may do all this curvy stuff elsewhere, but I know it's at least going to hit right there. You know, it might do this or whatever, but I know for a fact it's going to hit at -3.
That makes sense.
Yay!
There's like another section.
It's adorable, isn't it? Momo's saying you're so cute.
Oh,
We love you.
I love y'all.
Okay.
There's another section that I was struggling with a little bit.
All right, let's talk. I'm going to start erasing while you kind of tell me a little bit about the other section.
Okay, so this one was saying, like, it gave me one of the factors of a polynomial, and it said to find the remaining factors of it.
Yes, ma'am. Okay.
So, like, how do I get started on that? Like,
we're going to do it, believe it or not, we're going to do it the same exact way we just did this one.
is it where, like, if it's like x plus 2, I'd take like -2 instead?
Yes, ma'am, it is. And everything else is just the same. Remember on that last one that we just did, where I originally she gave you what was it, 3, I think, and then -2, and we figured out 3 worked. And no, actually, I lied. She gave you -3.
Yeah.
And a regular 2, if I'm not mistaken. So when I said, oh, if that is the 0, but if I were to write it as a factor, it would look like that.
Yeah.
That's now we're kind of getting into that. We're connecting that. So what is the problem? Exactly.
Well, it's okay, but what if the x has a coefficient?
Ooh, that's ugly.
Yeah.
Okay, just read me the problem.
Okay. It's p of x equals 2x cubed.
Okay.
Minus fx squared minus
how much x?
f. I mean that. I said f. Oh my gosh. I'm so sleep deprived. I'm sorry.
Hey, I understand. You know what? It just makes me feel better about myself because that is so something I would do.
Okay. I meant 5x squared.
How much?
5x.
Okay, 5x squared.
And then minus 14x plus 8.
Okay, and what was the factor she gave you? Did she give you any?
It's 2x minus 1.
2x minus 1. Oh, you know what that means?
What?
That means we have to do long division.
Ew.
Momo said ooh, and you said ooh at the same time. Oh, I love y'all. Okay, we can do this though, Simone.
Yeah.
You can't use synthetic division when it has a coefficient, or if it's, oh, I just threw my stylus across the room. I'm sorry. Like say, if it's like a trinomial, if you're dividing a trinomial or something that has a leading coefficient, you have to go back to good old long polynomial long division. Woohoo!
Okay.
You thought I was going to have better news for you, didn't you?
I was hoping.
Well, I'm sure there is a way to do this. Like, I think, well, actually, I guess in all technicality, you could do it. You could, yeah. I don't know if you'd want to do this. Let's do it both ways and see if it works.
Okay.
You might be able to do synthetic division on 1/2. And I say that because if I set this equal to 0 and then solved, it would be x equals 1/2. So if you wanted to do synthetic division using a half, do you want to try that? Or do you want to do long division?
Let's just do long division.
So all of a sudden, now that I introduced a fraction, long division looks delightful. Yeah, I understand that. If I say fraction in my class, Braden Ryan says, Miss Sparks, don't cuss.
Oh, Braden.
I know. All right. So we focus on, the first number when we're doing the long division. So what we're trying to do is find what can we multiply 2x by to get this 2x cubed. And we would multiply by an x, correct? Or an x squared.
Yeah.
Okay, so x squared times 2x is 2x cubed. And x squared times a -1 is a negative x squared. So we're going to subtract, and that brings down this and makes it a 0, which that was what our goal was. And then we've got a -5x squared minus a minus x squared, which would then turn that to a plus. Okay.
Right.
So that's going to be -5x squared plus x squared is going to give us a -4x squared. And now what can we multiply 2x by to get a -4x squared? And that's going to be a -2x. So -2x times 2x is -4x squared. Oops, I forgot to bring this down. I'm sorry. 14x. And -2x times -1 is going to be +2x. And so these two are going to cancel because that negative makes that a positive and this makes this a negative. So that's going to give us a -16x. And then we're going to, what can we multiply -2x by to get a -16x? And that's going to be a -8. And I needed to bring my 8 down. -16x. And then -8 times -1 is a +8. So that turns out to be 0, right?
Yeah.
Okay, which we're glad about because she did say it was going to be a 0. But now we're left with x squared minus 2x minus 8. And all we have to do to find the other zeros is factor that. So what we're looking for is what two things that multiply together that when we combine them, or, combine by adding or subtracting, would give us a -2. So we think of our factors of 8, and we absolutely know it's going to be, one's going to be negative and one's going to be positive because that's the only way we can get that, a negative 8. And the
Positive.
bigger one of the two is going to be negative 2. So negative 8, 1, that's going to give us a negative 7. Negative 4 and 2 would give us a negative 2. So it's that. So x minus 4 and x plus 2 are the two other factors. Does that make sense?
Yes, that makes sense.
So if she's asking you to list all of them, you would want to relist the original as well.
Okay. That makes sense.
And this is where that polynomial would cross the x-axis. It's cross at a half, at a negative 2, and a positive 4. So the zeros are 4, negative 2, and 1/2. So your factors are these, and your zeros are these. And it's where it crosses the x-axis. It's the roots. It's, all of those. It's if someone asked you what the solutions to the polynomial were, you would say this down here, the zeros and the solutions.
Okay. That makes sense.
Yay. Any other ones?
Let me check the lesson plans really quickly.
Okay.
I don't know if we had to do like this bookwork, but like I don't really want to do
All right. Well, I'll wait right here. And we'll do it together. My geeky self is going to do the synthetic division way just to see if we get the same thing.
Go for it.
That's what makes me the math geek, right?
Okay, so we don't have any bookwork, so I think I'm good.
Okay.
Thank you.
Great. Thanks for coming to see me.
Thanks for your help.
No problem. Love you.
Love you too. See you tomorrow.
All righty. Bye-bye.
Bye.